Okay, remember in the last video, we showed you a shortcut to factoring when your leading coefficient was 1. I'm going to show you a shortcut now for any time you're leading, for any number your leading coefficient is. Okay, all right, and this is why we get that shortcut when your leading coefficient is 1. Now that we kind of understand the principle of how to factor, and factoring by grouping and what we're doing, let's just see if we can get a shortcut. First step in factoring, don't forget to always look for a greatest common factor, but there's no common factor in any of these terms. Because it's a trinomial, that's what tells me that I'm looking for my two numbers. Numbers that multiply and give 18 times 2 and add to give 13. Some of us may know right away, some are going to be better than others about our multiplication tables and factors. And if you know right away that's 9 and 4, go with it. But if I don't know that, I'm just going to go through a systematic list. 1 times 36 is 36, but 36 plus 1 is not 13. 2 times 18 is 36, but 2 plus 18 is not 13. 3 times 12 is 36, but 3 plus 12 is not 13. 4 times 9 is 36. Oh, 4 plus 9 is 13. So once I find my numbers, now remember, our shortcut from last time said that I could really just put those numbers in my factor. I know that this p squared has to be p times p. So let's put a plus 4 and a plus 9. But that's obviously not the correct answer, because let's start multiplying it out. P times p is p squared, and I need it to be 18p squared. So the shortcut is I can just plug these numbers in, but don't forget to go back and divide by that leading coefficient. Okay, divide by the leading coefficient. Now, let's reduce the fraction that I got here. Both of these are divisible by 2, so that would make it 2/9, and this would make it 1/2. If this reduced to a whole number, I'd have my factor. If it remains a fraction, then I take that denominator and move it in front of my p term in this case. Okay, so that would give me 9p plus 2 and 2p plus 1, right? Because I'd move the 9 and then the 2 would stay. I'd move the 2 and the 1 would stay. Let's see if that worked. Okay, 9p times 2p, 18p squared. 9p times 1, 2 times 2p, 2 times 1. And if I add these together, that's 13p. So here's my 18p squared plus 13p plus 2. Perfect. Notice this is really what we do when the leading coefficient is 1. It's just, hey, if I divide by 1, of course that's always going to simplify to that whole number. Okay. All right, let's try it again. Don't forget to check for a greatest common factor first thing. But I don't have a common factor. So I need two numbers that multiply to give 5 times 28. If I have to go down here and see what that is, that's fine. 28 times 5. 5 times 8 is 40. 5 times 2 is 10 plus 1, so 140. And that add to give 39. Okay, so at some point when we are working on this factoring, we need to get a little bit better at guessing our numbers over here. Okay, I could start with 1 here. Okay, 1 and 140. But notice that's going to be 141. It's a long way from that. So I might get a little bit closer to these numbers by just coming up with some. And 28 and 5 is a great choice. Look, 28 and 5 is where I got that number from. So 28, I know 28 times 5 is 140, and 28 plus 5 is 33. Oh, those are really close to the numbers I need. Really close. Let's just change that a little bit. Let's take a 2 out of here and move it over there. So that would make it, if I took a 2 out of here, 28 divided by 2 would be 14. And 10, oh, I'm at 24. Oh, I got farther away. Okay, so let's think about this. Let's take 140 and write it in its prime factored form. Let's see all of its factors. And then I can play with them. Right? Now notice here's the 28 times 5. And here's the 10 times 14. So let's rearrange that to, and this, it just takes practice. Notice there's a 35 and a 4. Oh yeah. Just practice. Just practice with finding these numbers. Okay, if my numbers are small, I can just go down the list like we were doing. But now my numbers are going to get a little bit bigger. And maybe going down the list would take a long time to find. This one wouldn't have been too bad. I'd have got it on 4. But I'd have had to figure out, well, I'd had 2 times 70. 3 doesn't go into it. Well, that would have been okay. Whatever is easiest for you. Okay. So now I know that this is G and G plus 35 plus 4. But I cannot forget, this is the most common error people do when trying to do this shortcut. I cannot forget to divide by 28. If you just always do this on those others, if you just divide by 1, if you just make this your rule, you'll never forget it. Make it your rule every single time and then divide by the leading coefficient, whether it's 1 or not. Divide by 28. Divide by 28. Okay, so now these are both divisible by 7. You get 5/4. These are both divisible by 4, so you get 1/7. The denominator moves here. So in the end, you wind up with 4G plus 5. And here you wind up with 7G plus 1. Now, with all this being said, if you do not like the shortcut and you got good at doing the factoring by grouping method, by all means, please keep doing that. Right? So just pick your method. Pick your method. There's multiple ways. There's even more ways than this to factor. So if you have a method you like and understand, use that. Okay. There's not a common factor, but it's a trinomial. So I need 2 numbers that multiply to give 24, while at the same time adding to give -10. Okay, these numbers aren't too big, so I could go through my list, 1 and 24, 2 and 12. Oh, 2 and 12, I'm already going to have it, right? Wrong. Okay, let's look at that. 1 and 24. That's 25 when I add them. 2 and 12 is 14 when I add them. So make sure all your signs match. Okay, really it's 6 and 4 that I'm looking for. Okay, so the more I do this factoring, the better I get at finding the numbers. If I constantly have to go through the entire list, that's fine. Just go through the list. Okay, once I find my numbers, I know it is plus 6 plus 4. But I've got to divide both of those by 8 because my leading coefficient is 8. So this will simplify to 3 over 4, and this will simplify to 1 over 2. So the denominator moves to the front to give me a final answer of 4n plus 3 and 2n plus 1. Final answer. Okay, same thing, we're just going to practice a few. It's a trinomial. There's not a greatest common factor, so I need two numbers that multiply to give 70 and add to give negative 19. Okay. This is another one of those that if I started out with just 1 and 70, that's 71. That's a long way from 19. So I might see, hey, I know 70 is 7 times 10. That's where I got the number, right? And that's really close to what I need. So let's just play with this a little. My only factors are 7 and 2 and 5, right? 7, 2, and 5. Oh, 14 and 5. That's 19. Oh, I need negative 19. So right numbers, wrong signs. Now we got it. So that is K and K minus 14 minus 5. We just cannot forget to divide by that 10. And simplify those fractions. They're both divisible by 2. So that would leave 7/5 or 1/2. The denominator moves to this position to give us 5k minus 7 and 2k minus 1. Cool. Okay, looks like we're going to have another one with big numbers. That's all right. It's a trinomial. If you have big numbers in particular, double check that there's not a leading common factor you can pull out there to make your number smaller, but there's not in this case. So what's 36 times 7? And don't forget also, I could think of this as, 6 times 6 times 7, and then play a little bit with that. But let's just see what the whole number is. 7 times 6 is 42. 7 times 3 is 21, so it's 252. Negative, because it's a negative 7. And it's got to add to be 4. So one of these numbers has to be negative, right? They've got to be close together so that when I add them, which really I'm going to be subtracting them if one is negative, so they got to be numbers pretty close to the same size. Let's look down here. If 36 is 6 times 6 times 7, hey, I can just get my factors pretty easily there. 2 times 3, 2 times 3 times 7. Well, let's see if we can get numbers that are pretty close together. I've got a 6 times 42. Those aren't close together, right? I've got a 9. If I did put the 3 and 3 together, that leaves a 28. Those aren't really close together. Let's do these 3. So 2 times 3, 6 times 2 is 12, and 21. I'm going to start writing them up here for us, sorry. 12, one of them's got to be negative, and 21, it's not 4, but they're a little bit closer together. And what do we have a while ago? 9 and 14. Okay, hey, this one's pretty close. I had a 9, oh, it was 28, that's why. 9 and 28. So that's also not 4. Okay, so let's try. We've done 12 and 21. Let's try these 3 times 2, so 18 and 18 and 14, right? I grouped these together to get 18. 3 times 2 times 3, and then that leaves 14. Now the way I've got it written leaves negative 4, but if I change the signs, I have found my numbers. So just get used to playing with those factors, right? Playing with those factors. So that means we have a D plus 18 and a D minus 4. But I'm going to divide both of them by 36. $18 divided by 36 is 1 over 2. 4 divided by 36 is 1 over 9. The denominator moves to the front. And we have 2D plus 1 and 9D minus 1. And I can tell that that's wrong because 1 times 1. So what happened? Let me look at this for just a second. 18 and 14 for one thing, although it's not going to change my answers, but that's 14. Okay, D minus 14 is 4. Oh, but that did affect me up here. Okay, sorry guys. So this is really 14. And now this is divisible by only 2, so it's 7 over 18. Oh, I'm sorry guys. So what goes in front there? All right, let's start over. Sorry. I might have to redo this whole problem for you. But let's try and see if we can reconcile this without too much confusion. Okay, so what happened was I put a 4 here instead of a 14. We knew it was 14. 18 minus 14 is 4. So when I put my numbers up here, 18, I should have put 14. Divide them both by 36. But when I simplify 14 over 36, they're divisible by 2, which leaves us 7 and an 18. So this is 18D minus 7. That looks much better. That gives us a 36D squared and a negative 7 on the end. Okay. Oh yeah, we got to be careful about what we write. Okay. Let's try another one. It's a trinomial. There's not a common factor. Don't forget that's the first thing we check. Is there a common factor I can factor out? So 15 times negative 4 is negative 60. And then it's got to add to be 7. Okay, once again, I could start with 1 and 62 and 33 and 20. 4 and 15. But it might serve me better once I'm used to doing this to start with. Maybe I know 60, one of them's got to be negative, is 6 times 10. Now 10 minus 6 is 4. I'm not too far off from what I need, right? So maybe let's move the 2 over here and get 12 and 5. Oh, that's it. 12 times 5 is also 60, right? And I knew that because if I had down here 2 times 10, then this is 2 times 3 times 2 times 5. And I can move that around. Look, here's 12 times 5. Now, I've got the wrong signs. I need it to be 12 and negative 5. But once I have those numbers, it's a plus 12, a minus 5, and I got to divide by 15. So 12 divided by 15, they're both divisible by 3. So that's going to be 4/5. These are both divisible by 5, so that's going to be 1/3. Okay, the denominator moves to the front and gives us a final answer of 5a plus 4 and 3a minus 1. Perfect. Okay. It's another trinomial. I look for a common factor. It doesn't have one. Notice this one looks different. Oh, because it has some y's. But as long as I've got an even exponent here, for us a squared, and then there's a y in the middle to match it, we're good. An x here, a y here, a y here, we're good. The only thing that's going to affect is my factors will look like this, right? If I've got a y in that last term, I'm going to have a y squared in that last term. I'm going to have a y in this last term. That's the only thing it'll affect. As long as there's a y to match it in the middle. Got to have that. All right, so I need two numbers that multiply to give, oh my goodness, 12 times 35. Let's see what that is. All right, so 2 times 5 is 10. 2 times 3 is 670. 35. So 420. It's got to multiply to give 420. And a negative even 420. And add to give negative 13. Oh shoot. It's got to multiply to give negative 420. We just did that. Okay, negative 420. And add to give negative 13 from right here. Okay. So once again, I know this is going to look like this. I just have to find the numbers, right? Okay, so that's what I'm doing over here. I really don't want to go down my list, 1 and 422 and 210. I could, but, and that's fine if I need to. 400, anytime a number ends in 0, let's think about this. Okay, if I add negative 42 and 10, I get negative 32, so that's not it. But let's come over here and think about it. 42 times 10. This is 6 times 7 times 2 times 5. Let's see if we can rearrange this a little bit. Here's 7 times 2, 14 and a 30. Let's try that. 14 and 30. Okay, so that's 16. Hey, I'm pretty close to what I need. Pretty close. So let's try the other possibility here, which is 35 and 12. One needs to be negative. 35 minus 12 is 13. Yay. Right? Notice where it came from. 35 and then 12. Okay. Now, it's the right number, wrong signs. Let's do 12 and negative 35 to get us our negative 13 that we need. All right, so get used to playing with those factors. And then I'm just going to put a plus 12 minus 35 in here. Plus 12 minus 35. I didn't leave myself much room. But I got to divide by 12. Now look, this simplifies to 1. So nothing comes to, if it simplifies to a whole number, that's my factor, x plus y. Okay, this doesn't reduce at all. So the 12 comes to the front, and we have 12x minus 35y. Perfect. Okay, one more. Ooh, big numbers. Oh, but look, there's some common fact. I know that at least from the x's, because if there weren't common factors, I couldn't do not even find your two numbers. It's an x cubed. Nope, not going to happen. But I see they all have an x, so I can factor that out. Let's see if I can factor anything out from the numerals. Okay, I know there's at least a 3, so let's just start with that. There might be a bigger number, but I know there's a 3. Remember, because 4 plus 2 is 6, that's divisible by 3. 7 plus 5 is 12, that's divisible by 3. Hopefully we know 18 is divisible by 3, but if we didn't, 1 plus 8 is 9, that's divisible by 3. Okay, so if I factor a 3x out of this term, it's going to leave 14x squared. Now, if I didn't know it, go over and say, what's 42 divided by 3? If I factor a 3x out of this term, it's going to leave 25x. And if I factor a 3x out of this term, it's going to leave 6. All right, now I'm going to check my numbers and see if that's the biggest net. 14 and 25, nothing in common. So I'm looking for two numbers that multiply and give 14 times 6. Now I can come over here and multiply it if I need to, but I know that that's 84. And it's got to add to be negative 25. Okay, so let's start with the 14 and 6, right? 14 plus 6 is 20. Hey, I'm pretty close to my numbers, right? So let's take that 14 times 6 and spread it out a little bit. 2 times 7, 2 times 3. Okay, so here's the 14 and the 6. What if we did 21 and 4? 21 and 4 is 25. I have the right numbers. They just have the wrong signs. Cool. Okay, so that means don't forget about this common factor we found in the beginning, right? That's going to carry on. But my other factors are x minus 21 minus 4. And I've got to divide by my leading coefficient of 14. Now, these are both divisible by 7. So that leaves, these are both divisible by 2. So that leaves, okay, the denominator. And finally, I have the 3x, 2x minus 3, and 7x minus 2. Perfect. Okay. Let me know if you need any help with that.